In this video, we'll look at recursive functions for tree traversals that are pre-order, in-order and post-order. So already I have an example ready. Let us start with pre-order. For traversals, I have taken an example tree with a linked representation. These are the nodes with the data inside the node, and this is the address of a node. Below each node, its address is written. This is a recursive function for pre-order traversal. So let us read the function, then I will show how this function will find out pre-order of this tree. See, function is taking a parameter that is root of a tree. So we will pass root to that one. Suppose if you are calling, then we call it as pre-order root. So we will pass the address of the root node, that is 200, to this one. So here the parameter name is t. Then inside the function it will check if t is not null. Means there is some node. If there is some node, then it will perform 3 steps. Print the data from that node. Second step, call itself recursively upon left child. Third step, call itself recursively upon right child. So these are the 3 steps it will perform. As it is recursive, it will call itself again and again until entire tree is traversed in pre-order traversal. We already know how recursive function works. We have seen their tracing. We have generated the tracing tree. And we also know that stack is used by recursive function. For each call, activation records are created in the system stack. So similarly, let us trace this pre-order function upon this tree. So let us generate a tracing tree. So for tracing tree, I will take a stack also. So here I will create a stack, that is system stack, to show how the activation records are created for each call. Let us start tracing that function using tracing tree. First time when the function is called by passing root is the address of the first node, that is 200. So the function is called with the address 200, pre 200. In short, I am writing just pre. First call, pre 200. So as root is 200, 200 is passed. So once the function is called, an activation record is created. Activation record will contain all the variables that are used by that function. So what are the variables used in a function? Only t is used. So that is the address. So I will write down just address 200. So activation record will be created where t value is 200. Then let us execute. First statement, t is not null. Yes, 200 is not null. 200 is not null. Then perform 3 steps. So 3 steps. First step is print data. Print data of this node 8. Then second step, call itself again on left child. Left child address is 210. Call itself again on 210. Then next third step, call itself again on the right child. We will do it afterwards. First let us finish this one. So this call, what happens? Again an activation record is created with the t value as 210. Before continuing, let me write down the output that we got. So far, value 8 is printed. Value 8 is printed. Now, for this call, 210, let us start the procedure once again. 210 is not null. Yes, not null. 3 steps. Print, call on left, call on right. Print data. So, 210, value is 3. Then call itself again upon left child. That is 270. Call itself third step upon right child. We will do it afterwards. First of all, this has to finish. Now for this call, activation record is created. This is with 270. For this 270 and the function is called again t is not null. Yes, it is 270. It is not null. Perform 3 steps. So 3 steps. We know the step very well. Now I will not be checking every time here. We know the steps. Print, call upon left side, call upon right side. I will be following these 3 steps every time. So now this is not null. So print the value 4. Call itself upon left child. What is left child? Null. This is null. Just I am writing P here for pre-order. Then again an activation record is created with null. Now this time T is not null. No, it is null. So it will not enter into this if and ends. So this function terminates without doing anything. So its activation record is deleted. Once this is deleted, it will go back to the previous function call. Previous function call was 270. In that function call, out of 3 steps, two steps are completed, printing and going on left child. Now what is remaining? Go on the right side. So P of, what is right side here for this node 270? It is here at 270. So right side is null. Right side is null. So again it will call itself with null. So again the activation record is created at the same place. A new activation record is created with a t equal to null. But this call is different. This was over already. This is a new call. So again for this call, t is not null. No, t is null. So it will not enter inside if nothing is done. So this will terminate. Once this terminates, its activation record is deleted and it goes back to the previous function call, that is 270, back on this one. As per 270, all three steps are completed. Three steps are completed. So this is also completed. Go back to the previous call, 210, this one. For this call, two steps are over, printing and calling on left side, this one. Now it has to call on right side, that is 300. So it will call itself upon right side, that is 300. So for 300, a new activation record is created at this place for different function call. Now this is not null, three steps. So I'll perform those three steps quickly. First one is print the value. So what is the value? 9. 9 is printed. Then call itself again for left child, that is 0. So activation record is created once again. But this terminates. So this is over. Back to this one. Third step, call upon right child. This is also null. So new activation record is created. This is null. So this terminates. So this is over. Go back to this call. This call, three steps are over. All three steps are over. So this call finishes. So this ends. Now it goes back to 210. This one. For this one, all three steps are completed. Printing, call upon left child, call upon right child. So below this, there are more steps that are finished. These are also finished. So this function call has finished. So it will go back to previous call, this one, main call. So out of this, two steps are completed, third step is remaining. So I'll stretch this little more here. So third step it has to perform, that is go on right child. PRE upon right child. Right child is 230. So new activation record is created above this one with a 230 for this call. This was already completed 210. So it is calling this one. This is not null. So not null means three steps it has to perform. Print the value, call upon left child, call upon right child. So print the value. So what is the value? 5. Right? Then call upon left child. Pre-order of left, that is 310. Right child afterwards. First 310. A new activation record is created with 310. For this again not null, three steps. So print a 310's value. What is the value inside that? 7. Then call itself for null. So T assign 0. New activation record is created. But this ends. So this is terminated. So this is deleted. Goes back to this call. Again P0 is called for right child. T0. This terminates. It ends. Goes back to this call. This is completed. So this is deleted. Then go back to this call. 320. So P for right child. 320. 320. For this one, it will print a 2 and it will call itself for 0 and 0. Okay. So two more zeros are created. Then they are deleted. This is over. So 320 is finished. So 320 is finished. Then 230 is also finished. Then this is also finished. Did not write the output. Let us check and write the output. First 8 was printed. Then 3 was printed. Then 4. Then 9 was printed. Then 5. Then 7. Then 2. So this is the output of pre-order. So tracing tree, it has expanded like anything. So once you know how this tree is generated, if you are familiar with this tree, you can even work out upon this tree structure itself. You don't have to generate a huge tree, but you have to do it at once. Then you get the idea how to do it directly upon the tree. Now let us analyze the tree. First of all, total how many calls are there? Let us check the number of calls. 1, 2, 3, 4, 5, 6, 7. Then 8, 9, 10, 11, 12, 13, 14, 15. Total 15 calls. Actually, if you see these with addresses that are equal to nodes, and these nulls are for nulls. So if you remember, we already saw that if there are n nodes, there will be n plus 1 null pointers. So total number of calls are 2n plus 1. N for number of nodes, then n plus 1 for number of null pointers. So total number of calls are 2n plus 1. Then once again I will show you in which order the calls are made. This was the first call, second call, third and fourth call, fifth call. Then this was the sixth call. Then this was seventh call and eighth call. Then go back and come this side. This is the ninth call, 10th call, 11th, 12th. Go back and come this side. 13th call, 14th and 15th call. In this order, these calls are made. If you know in which order the calls are made, then you have understood the procedure, how it is working. Then let us look at the stack. How many activation records were created and destroyed depends on the number of calls. Total 15 calls. So 15 activation records were created and destroyed. But you see, at a time, how many activation records were there? 1, 2, 3, 4. 1, 2, 3. 3 levels are there. Plus 1. Because for nulls also calls are made. Right? So it depends on this vertical dimension of a tree. That is height of a tree. No doubt it is 4, but the height is 0, 1, 2. Height is 2 only, but they are 4. Don't go on count. Don't go on count. It is dependent on height. So I can say that the size of the stack will be height plus 2, whatever the height may be. So if I write height plus 2, then I can say that it is dependent on height value. That 2 is constant, always 2 you will be adding. So the actual size depends on height. So yes, saying that depends on height is not wrong, right? So don't go on the count always. So how many activation records are created? What is the size of the stack? It depends on the height of a tree. That's all. This is the procedure I have analyzed. So in the next procedure, in the coming procedure, I may not be showing stack every time. You know how it works. I'll try to keep the same example so that you already know about this and you already know the tracing tree. So with the minimum work, I will try to show you the tracing of remaining functions upon tree.